I think we can start. Hello everyone, thank you all for joining our webinar. My name is Bojana. I work for Syntelli Solutions and I also manage the events for ABD Society. For those who don't know, ABD is a nonprofit based in Charlotte with a mission to establish Charlotte as a national analytics and big data hub. Thanks to UNCC, we are hosting these events monthly. And our next event is April 23rd. Hopefully this current situation will be better by then and we will meet in person at UNC City Center building. Otherwise, we can still meet here on Zoom. Today we have Ibrahim Sadikov. He is a data scientist at Genpak and first place winner at the Queen City Hackathon this year. He has a strong financial background and more than 3 years of experience using predictive modeling, data processing, and data mining algorithms to solve challenging business problems. So I will hand it over to Abe now. You can go ahead, start your presentation.
Thank you, Bojana. So, hello everyone, once again.
I think you're still on mute.
Oh.
Because I cannot hear.
Can you hear me? Hello?
Hey, Abe, it's Maithili. I can hear you.
Okay, thank you.
Yeah.
So, let's start. So, first of all, thank you for everyone for participating in this webinar. And I'm very happy to share my experience, how I won the hackathon recently that took place in Red Ventures. And thanks to ABD Society for organizing this event. And let's start it. So if you have any questions, please feel free to ask at the end of the webinar, or you can just write your questions also on the chat, okay? So let's start. So let's a little bit talk about myself. So my name is Ibrahim. I go by Abe. I'm currently data scientist at Genpak, and at the same time, I'm pursuing my master's degree in data science from UNCC School of Data Science. And the most of the thing that I was able to do in this hackathon was thanks to this brilliant teachers and professors at the school that I'm attending right now. Also, I have my bachelor's degree in economics with finance. I'm from Samarkand, and that's why our team name was Samarkand. And honestly, I'm passionate about data science. I love Kaggling and being engaged in Charlotte's data science community as a ABD Society, PyData, and R meetups. So at the end of the webinar, I will be sharing the presentation deck and also the reproducible code for my application, Shiny application, on my GitHub. So please, if you're interested and if you want to deeply dive into the topic, visit my GitHub page and get connected. So let's talk about the agenda. First of all, I will be talking about the competition, and then I will be talking about the objectives and how leading opportunity needs our help, and my remarks and outcomes about this event. And also I will talk about the platform Maya and how I implemented H20 LIME and Shiny to give a tool for operation team to perform the analytics stuff. And also I will demonstrate you the demo version of it. So it will be pretty interesting, a little bit technical, but not too much. I don't think that I will not overwhelm you with that. So let's start. Let's talk about the competition itself. So you can see Dan on the left-hand side. He was a keynote speaker for the event, and a lot of things that really was important from his speech that I was able to integrate in my solution. So let's talk about a little bit about economic and social mobility and how it is important for the Charlotte community. According to the Leading Opportunity team and their executive summary report, there are 25% of Charlotte children experiencing poverty. And what does the economic mobility itself can be defined as? So economic mobility is the situation when the family or a person should improve their economic situation, which is like income, for the duration of their from childhood to adulthood. So, and it was interesting that like the poverty rate of working age African Americans and Hispanic is twice that for whites in Charlotte, and almost 15% of young people aged between 16 and 24 are neither working or not going to school or training. So we can see that it's a big issue for our community right now. And that's why a Leading Opportunity team challenged hackathons, hackers like we are, to somehow define this problem, maybe came up with some kind of tool or solution to solve this, to help them to solve this problem. So there were 3 tracks in the hackathon, like open-ended and the Kaggle competition, and the third one is like AWS racing. I chose to be the part of open-ended track, and the main problem that was defined by the organizer was that how we can solve the problem of economic mobility specifically for Charlotte. Because what the thing that I was surprised is the Charlotte ended up with 50 organized, like in research. There were like 50 cities were on the research, which was conducted in 2014 by the Harvard and UC Berkeley professors. And unfortunately, the upward mobility was very low in Charlotte. So this was really ridiculous. Like, I am surprised from that, because we are like second financial district and we have so many good businesses there. But unfortunately, we ended up with being a 50. So this is really interesting. So to address this problem, Leading Opportunity came up with 21 community strategies for economic mobility for Charlotte. There, as you can see on the right-hand side, there is a like good visualization that shows how they're trying to prioritize their strategies. Like they're defining strategies like early care education, child and family stability, and also college education as a major important factors that can be as a determinant of upward mobility. So they challenged us to create a tool or policy or predictive model that can help us to deal with the low level of upward mobility. So as you can see from highlighted, I chose to create a tool and can be also integrated with predictive model so that somehow to contribute to this issue. So let's talk about my competition workflow. So at 9 p.m. We kicked off like actual work. So I chose my track. I did some research about economic mobility, and because Dan was a good speaker and he was mentioning about actual pinpoints of the issue. So I made some research on the Google and looked for some solutions that were proposed by the other professors or researchers. And at 12 a.m. I did some literature review and tried to identify how can we define the economic mobility. Yes, we were understanding what is economic mobility, but how can we define it in terms of like in terms of data science, right? So from 2 a.m. I started dive deep into the competition itself and did some data exploration. I searched for external sources. We were provided with Charlotte data sets like Charlotte Data Hub, but unfortunately it was not enough for us to make our analysis. So I searched for external sources as well, and I started building my app. So until like 8 a.m., it was all about building, debugging, and integrating LIME and H20 to my Shiny app. So in simple picture, I can describe my process, as you can see with the Jiri carry. Yeah, it was really like, let's say, a little bit challenging, but persistence and determination helped me to overcome it. And successfully, I was able to win the hackathon. Yes, congratulations to myself. I was really happy, and I was really like shocked, like I was alone. I can see the power of one, right? So it was really exciting. That was a very happy moment after not sleeping like 12 hours, or more than 12 hours actually. So yes, but the problem, I faced a lot of challenges actually in this hackathon. As you can see from this iceberg analogy of the competition challenges, there were like visible problems, challenges actually that I was facing, and also below the line, the problems that I came across after several hours of research. First of all, I would like to mention about data quality. Data we were provided with multiple data tables. Unfortunately, they were not a good quality in terms of like, they were not primary keys, so it was very difficult to join the tables. And actually, there were a lot of determinants of economic mobility, like education, income levels, like gender, and many other like independent variables, let's say predictors. But unfortunately, we couldn't find the way of labeling our dependent variable. How can we define the economic mobility, right? And secondly, time constraints. Usually it says 24 hours, but it never lasts 24 hours. So actually you have like 12 hours or even less to actually work on the problem, because most of the time will just flies away from like either like organization issues and etc. So time constraint was another big challenge for me to make something that is really tangible. And an open track complexity by itself, because open track is like you have to come up with a solution from nowhere. So you are not given like specific problem, you are not given like specific data set that you can use, like Kaggle, right? In a Kaggle you have already the data set there, so you have to just do your best to improve your score. But in open track you have to be more like think out of the box. You have to be more curious, you have to be more challenging towards yourself, how to propose your solution. So it was another problem. Actually, I spent like 5 hours of my time understanding what I'm going to do and how I'm going to do it. So that's really important. And also, another problem that I was facing is whether to choose, should I build a predictive model or should I build just the app that can integrate both? So I came up integrating both of this, and I will tell why I did this in the further steps of my slides. And also the main problem for me in the duration of this hackathon was how to define economic mobility. That was a big issue for me, because we were understanding what is economic mobility is, right? So what is it, we know, but how can we express it in analytics term, like mathematically? That was a big challenge for me. So this is the challenges that I faced.
We have a question from Chris. Can you elaborate on what you mean by not being able to label your predictors or economic mobility?
Yeah, so good question. I will address this question in the next slide. Okay, so he's very close to that. So, and that's why I came up with objectives. So I had 3 main objectives. First of all, my objective was, as a hackathon, when I came here, so I wanted to give something that can be used long-term, that can be really implementable, that is tangible. So that's why I came up with building a Shiny app, so that it can be used for like operation team who has very maybe no knowledge of any programming languages, so that they can use streamline their analytics stuff. And also, as a question, to answer your question, defining economic mobility. So there were a lot of like independent variables, like let's say determinants of economic mobility, like education, other like social behavioral factors, etc. But towards what we are trying to predict this determinants was a problem. So the label means here our dependent variable, what we are trying to predict. So we are trying to predict economic mobility, how like economic mobility can be measured. But the problem is, how can we illustrate it mathematically so that we can input it to our model to make our predictions? So this was the main issue for me. So first of all, I was thinking about getting the income as a proxy for economic mobility, because income is also like partially the factor of that can we measure economic mobility with. But it's not actually what we want, because economic mobility says how a child from his childhood towards the adulthood, how his economic situation changes, whether he goes to upward mobility or whether he will not change his situation. He will be ended up with a poverty level or low social mobility. So this is a main factor. So the main factor was, how can we define economic mobility so that we can input it to our model as a dependent variable to perform our analysis. And if someone is attending this hackathon, who attended this hackathon and now participating in this webinar, they really understand my point, because in Kaggle competition, they had a like label, but it was not illustrated what kind of actually dependent variable it is. So this was a big issue for me, the second issue. And the third one, my strategy was, when Dan was talking about the economic mobility, he mentioned that we have a lot of determinants. We already built it up as a strategy. But the main pinpoint that we are facing right now is to understand, prioritize our strategies. Because our budget is constrained, our resources are constrained, so we have to understand what factors are important and what factors are that we have to start with to somehow narrow down our scope, because we have a constraint in terms of like resources and budget. So these are the three main objectives that I try to work on during the hackathon. And so the main thing is what I was able to do and what I was not able, what I missed in this hackathon. So despite my first place finish in this hackathon, I'm really eager towards the community, the data science community here in the webinar right now. Maybe if you're interested in this problem, maybe you are like trying to help the Charlotte community to deal with this problem, please join me. Please, maybe we can come up with better data sources, or maybe better ways of dealing with this problem. So as you can see, what I was able to do is like I did empirical approach to define economic mobility. I read a lot of literature reviews and came up with a way how to represent economic mobility. And also, I was able to build a scalable and easy to navigate platform as a service infrastructure that can help the maybe leading an opportunity team to navigate through their analytics easily without writing any code, right? And we can improve it even in the future. And I also built end-to-end data analytics pipeline. Even the person without very low or zero skills of understanding data science, how it works, can run this all the tools. And also I integrated robust H20 ML machine learning so that to automate our analytics pipeline. And what didn't work? So the main golden rule of every data scientist is, of course, the garbage in and garbage out. Yes, I build the fundamental infrastructure, maybe let's say to run our models or do some descriptive analytics there. But unfortunately, the main value that can be derived is from the data. Unfortunately, our data quality was not good enough. it has from plenty of sources which are not ready to use for modeling. And also data quality was also not very good for us to implement our modeling. It was also lack of observation, only like 400 observations. I think it's very low to conduct a very like, let's say, more fair approach to analyze this problem. And also I was able to define the economic mobility, but unfortunately, given the problem of dataset problem, I was not able to actually leverage my understanding of economic mobility as a dependent variable. So I will talk about this in more deeply in the next slides. So until here, do you have questions?
Question. Yes. I don't know if you read it. So Chris is asking, what's the 2014 study definition of economic mobility as proportion of citizens to move from bottom quintile to income to top quintile of income unsatisfactory for some reason?
It's in the QA part?
It's in the chat part. Do you want me to read it one more time?
Yes, I wasn't able to hear.
Was the 2014 study's definition of economic mobility as portion of citizens to move from bottom quintile of income to top quintile of income unsatisfactory for some reason?
Yeah, that's correct. And I will, in my next slides, I will show how they also defined another way of measuring the economic mobility. I will tell about this later, okay?
Sure.
So now we understand the competition, right? And what we were able, how we were able to deal with, how I approached this problem. And now let's talk about more deeply about the solution, about that I was trying to propose. So I call it Maya because you can see this girl. Dan was speaking that in his keynotes, he was mentioning about Maya, and this was like she was the face of leading opportunities. So I just also think about it and named my platform after Maya. So it's Maya 1.0, and I call this project as Tackle 50. So we're in the 50s place. So we're trying to somehow challenge this problem. So back to your question, defining economic mobility. So you can see the original paper that was conducted by the Harvard professors and the UC Berkeley professors that they tried to analyze how the economic mobility can be measured. And they used the solution proposed by Solon. He tried to measure economic mobility as a child income regressed towards the parent income. So he proposed labeling the economic mobility as a income elasticity towards the intergenerational gap. So we take the log of the child income and regress it towards the log of parent income, and in this case we can come up with the economic mobility as a mathematical representation. And the main pinpoint for me was actually getting differentiating the child income from the parent income, because the data set that we were given with unfortunately didn't have such kind of opportunity for us to derive this measurement. And also I can point out here that there is another data set that is openly available in IRS dataset, where we can somehow derive it. But due to the time constraints we had during the hackathon, I was not able to actually leverage this data set. So actually it was very hectic time. So during the 9 hours, you have to come up with something that is tangible, and you have to choose which is important, either to clean the data and doesn't have anything, or just give something for a start as a milestone, so that we can then work on this issue more afterward, right? So this is how we can measure economic mobility in terms of empirical approach. So actually now I understand how can we measure economic mobility. But the next point right now for us is to understand how can we do it in real world scenarios. So in this case, I built the Shiny app, which this is a high-level infrastructure of the application, and it's a web application. It's done by R, so all the programming, coding stuff I did in R, and all user interface is done with HTML and with integration of Shiny. It has 4 parts. It has data view, like data map, EDA, exploratory data analysis, where we used Esquisse and some of other descriptive analytics packages developed by brilliant R community. In the third part, we have H20 Auto ML that is integrated to our Shiny app, and we will also examine it more deeply. And also the last one is LIME, and I will talk about it later. Maybe some of you are already familiar with these tools, and if you're not familiar, then it will be something new for you guys. So first of all, let's talk about the Esquisse. Esquisse is a very good package that incorporates the ggplot2, which is one of the very straightforward packages in R visualization, and it was developed by the Dream R team. It's maybe some of you are guys familiar with Tableau. It's like a Tableau, but done with R. And interesting thing is, I was never interested in how can I use it in Shiny, and actually during the hackathon I was able to leverage it, and it worked fine. So it's a very simple to use. Why it's simple to use? You don't have to write any code to visualize your data or variables. So you can easily drag and drop there. You can even save your code. You can rename your labels, and you can even save as an image. So it's very straightforward, very similar to Tableau, and it's free, of course, so you don't have to pay for it. So that's awesome. So you just simply drag and drop, and this package will do the rest for you. So what I did, I just integrated it with my Shiny app, and you will see it in a demo in more detail. And if you're interested in this package, please visit their GitHub page so that you can use it also for your daily basis or just for learning purposes. Okay, now let's talk about H20 Auto ML, which is I like about this, talking about this, because whenever there is an easy way to do something, I'm always for it. So let's talk about automatic and scalable machine learning with H20 in R. So what is H20? Maybe some of you guys familiar with H20, maybe some of you are not familiar with it. It's like a machine learning pipeline that uses minimum human effort. So you don't have to, if you want to, you can code. If you don't have to, you can just go to their friendly user interface and do all the machine learning stuff in a very easy, in a very straightforward way. So here, what is very important that I will be talking today is very important thing is H20 is open source, and also you can easily call their API in R or Python. It's built with Java and also with H2O. So what I did here, I used H2O with R, and at the same time, you can use it as H2O flow. I will describe it a bit later. And yes, so this is our automatic machine learning pipeline. So it's very easy and straightforward. So at the back end of my application, this is a process how it goes. So you load the training test dataset. You will specify the response and predictive variables. Response means what we're trying to predict, and predictive variables is what kind of variable we're using to predict our label, which is dependent variable. And we just click the run AutoML, and we will add some kind of criteria there. And that's it. We just generate the leaderboard. And we can also explore our models and choose our model that we are trying to use. And even we can save it and also easily productionize our machine learning model that we saved. So it basically, if we just consider it as a whole machine learning pipeline, so this done, I already did it for my application, and this done automatically by the AutoML. So it's just the model training here. It's just it uses simultaneously multiple models to train our dataset on, and if you want to choose the leaderboard, the leader model, you can just specify it and do your prediction. It's very straightforward, and this is like our backend pipeline that is running our Shiny app. So as you can see, it's not a big deal, right? It's very simple. You don't have to write many codes. You don't have to write like a bunch of script there. It's easy to use. You just call the library H2O. You just specify a training set, and you just specify your response variable and the training frame. And also you can specify how much time you are trying to run your model and generate the leaderboard. And later, yes. So this is in let's say in R. So in R, you have to write the code. But let's say you don't want to write the code. So what you will do is you can use the H2O AutoML flow. It's a very good graphic user interface. So if you don't want to type a code, you can just go free version of flow, where you can just drag and drop or just choose your whatever did I here, you can just do it without writing a code. So you can call flow from your Jupyter notebook or from your R Markdown. It's very easy. And then you will be generated with similar leaderboard. So you can see that the H2O will train similar and multiple models and will generate you with the leaderboard. And you can see from top to the bottom what models are like scoring the highest scores. So for example, in this case, we are choosing the area under the curve as a sorting metric here. So it sorts the model performance towards the AUC. So that's how it looks like. So, and you may ask me why I chose H2O. It's very simple. Yes, there are many other packages, like you can mention in R, there are like Caret, or maybe in a Python like scikit-learn. So why I chose the H2O? Because it's very straightforward for me. So you can generate the various models simultaneously and automatically. And also it's fully open source. For example, there is a similar other products like Data Robot, right? So maybe you're familiar with this kind of product too, which is now trying to automate the whole data science pipeline, right? But it's not free, right? So you have to pay for it. But H2O is for everyone. It's because it's open source. And it's automatic training and tuning of many models. So you don't have to make like hyperparameter tuning there. So it's all done by you. For a start, I think it's very good for data scientists, because then they can have more time actually doing feature engineering, actually understanding the problem, because I think it's more curious rather than just running the different kinds of models, right? Because at the end of the day, as we can see now, machine learning is all about now advanced feature engineering. If you're good at feature engineering, if you're doing advanced feature engineering, then your also predictive model is much better performing. So let's spend more time actually on feature engineering and understanding the problem, business problem, I mean. So it's scalable in your local compute, like it's in memory processing, so it speeds up the computation. And also what I also like about H20, and that that's why I leverage it in my Shiny app in this problem, is you can use Docker, you can integrate with Docker and with Shiny app to productionize your models. And it supports a lot of statistical machine learning algorithms like gradient boosting machines, general linear models, deep learning, and etc. Also, here, it's not specified. You can also choose the maximum run times. It's here, for example, I want to try to train my model only for 10 minutes, but you can train it for 1 hour and or maybe 90 seconds. For example, in my Shiny app, it only trains now 90 seconds because of the time constraints. And also, it handles imbalanced data easily. For example, if you want to use the, let's say, caret, so you have to do undersampling or oversampling, or you have to use other like packages like Rise or Mice to clean your data, to deal with missing values, or to balance your imbalanced like dependent variable, right? So what it helps you just with the automatically, it just also balances the imbalanced data. It's usually the major case when you are trying to analyze the fraud data sets like AML, right? Or maybe credit default risks. In that case, it's also very helpful for you. And also another very good, last but not least, very good point is H20 is scalable in terms of that you can choose their metrics, how you want to score, how you want to actually leaderboard, how you want to sort your leaderboard towards which kind of metrics, like root MSE or AUC or just the log loss. And for further documentation, you can just refer to this link and get more out of it. So at the end of the day, what you will do is you will just press the red button and just relax, because driverless ML will do the rest for you. So actually, for a start, or for novice data scientists, as we are, or maybe professional data scientists can definitely benefit from this like meaningfully. So do you have any questions so far about H20 or? Okay, so now let's talk about the...
There is one question.
Yes.
Also from Chris. Just a second, it's in a Q&A section. H20 handles imputation?
Yes. Yes, but it's not included in H20 AutoML, but generally it handles. So
there is one more from Jacob. Great presentation. Do you
yeah, I got his question. Yeah, Jacob, that's a really interesting question. The main problem is data. So I spend more of my time actually working on the platform because the data set was not like the data sources that we were provided with is not like in good quality or that can be leverageable to address this issue. So that's why I want to challenge you guys also. Maybe we can team up and try to come up with good data engineering and try to refer to external sources to somehow better improve the data quality. That's the big issue. And in the demo version, I will also will demonstrate with the data set, but it's a data set I use from Kaggle competition. I will talk about data set later. But the main question, even right now I am facing, is about the input. The data set is not like very good. So I built up the infrastructure, but we need a data set that is really good, that we can make our accurate analysis and do some very good predictive analytics on it. So let's talk about the LIME. So we are running out of time because, so we are talking about the LIME. Are we talking about this LIME? No, let's talk about this LIME. Yes, we always see it in our Charlotte streets and it's a very good scooter, right? No, actually we're not talking about this LIME. So we're talking about like different LIME, which is local interpretable model agnostic explanations. It's a very good paper which was published in 2016. And even the name of this paper is very interesting. Why should I trust you? It's like, actually it's a very good, like a very good topic in today's like machine learning, data science world. How can we interpret our models? And the most important thing here is locally. How can we locally interpret our machine learning models that we built? So we did data processing, we did some feature engineering, we built up the model, we generated the predictions. Is it all? There is one more thing. And the main question is, can you explain how your model works, right? If you're a business person, even if in the hackathon, when I was in the hackathon, the main question is, can you explain how this model works, right? How can we make an assumption whether this model is accurate or can we trust on this model? And that's the very important, and that's the middle and very central question that nowadays, not only the business people, but also regulatory authorities also very strict with. So let's talk from general perspective. So we have data and we put the model on some kind of black box model. We are just getting the predictions, but we are not actually understanding how the internal is happening, how the model is making its predictions, right? Because neural networks and like assemble models, or all of them are maybe getting a good prediction, but what's happening behind the scenes? What's happening actually, how they are making their prediction? That's the main and very central question. And also, it's the two sides. What is important? Interpretability is important or accuracy is important? Can we develop our trust on the accuracy? There was a very good speech from, I think, in the beginning of the fall, organized by the ABD Society, which was specifically targeted in this topic. Is machine learning is fair? Is it making a fair decision making? Is it making a fair understanding predictions? And at that time, I was very much interested in this topic, and I did dive on that, and I came up discovered for myself this kind of LIME kind of packages or tools that we can use it. And it's very important point, because accuracy is not always, it can be right, it can predict well, but it's our predictions cannot always be generalized, right? Because of overfitting, because of correlation, because of the bias. The bias actually is the main problem. What is the bias by itself? For example, we are making our predictions referring on some kind of bias. Maybe our data is biased by itself. That is very maybe negatively or impacting on the truth of the model, of the prediction. It can be accurate, but it cannot be the truthful. It cannot be reliable. That's the very important segment that we are trying to look right now. So let's say there was a very big topic. Can you build your trust based on accuracy? On this paper, they give us this example. So we were given like to differentiate huskies from wolves, right? And when we ran the model, we made only one mistake. So only one time the model predicting wrong way. Like it took the wolf as a husky as a wolf. So, but all other times, like 5 times, it was correct. But so in many cases, even in the beginning, I was in the same direction. I was saying like, okay, now my model is predicting accurately. I did my job. I'm great one, right? No, there is another side of this coin, which is very interesting to look at. So, but there can be another option, like the bias in the data. So what is the LIME can help us is to look at each observation and see how the model is making its prediction. For example, if we look at the husky, we see the husky picture, right? But it's predicting as a wolf. And also if we look at the explanation of this picture of this prediction, we can see that pictures of wolves show something different in the background. So the background, so according to this background, we are making the prediction that it is wolf, not a husky. Yes. And what is the important thing is here, actually, we are not building a good classifier that can differentiate the huskies from wolves, but actually we are building a great snow detector, right? Because actually, where there is a snow is detecting as a wolf, and if there is not a snow on the background, it's detecting as a husky. So even if our model was accurate, it was not reliable, because even if the accuracy is high, but our model is very biased. So this is a main problem. And this is I try to integrate in my Shiny app as a LIME package to somehow to elaborate on this. And this is a very high level picture for you guys to understand how I did it. So it's a common sense, like some models are easy to interpret, right? Because linear models, logistic regression, single decision trees, they're easy to interpret. Why? Because there is a weight on each feature. We generate the coefficients, right? So we can see how the variable is impacting on the dependent variable. We can see the contribution of each variable. And also, there are some models that are harder to interpret, but still we can interpret them, right? For example, random forest or gradient boosting machines, they come up with feature importance. But the main problem is this feature importance is global. They give the feature importance for global model. They don't give it for local each observation. So that's very important. And they don't tell us how each feature is impacting on our decision. And that's why it's called non-parametric models. And also there is some are really hard to interpret models like neural networks, which we call as a black box model, which are very difficult to interpret. But what is a good thing about the LIME, it can leverage easily different kinds of random forests, gradient boosting machines, even neural networks, deep learning models to try to interpret it locally. And it works with text analytics. It's good work. It also works with image classification. So you can leverage it on your work also. So basically what is local agnostic model explanation is taking into account the model, it makes its prediction and understand how each feature is impacting on a single observation. Whether it's making a prediction accurately if we look at each observation. So it explains why a single data point was classified as a specific class. It's very important. So we are running out of time, so I will just skip this part, how to how the actual LIME works. So if we have time, I will just definitely go here. And also let's conclude about the LIME. So what is the major benefits of LIME? LIME gives us the, like, let's say, confidence towards the model, whether it's predicting well or not predicting well. Also, it helps us to debug our model and spot any biases on the model. And right now, it's like GDPR, like is a regulatory requirement to use interpretable machine learnings like LIME integration or Shapley or LE5 to make our black box model more interpretable, especially in credit risk, in financial industry. It's very much important. So also you can, as an alternative, use Shapley additive explanation or LE5 to compromise if you don't want to choose LIME. So at the end of the day, we limed it, guys. So we know what it is in a very high level, but you can, guys, deep dive on it and to understand more. So let's go to the demo because we are running out of time. Can you see? So the first thing is you will select the data set. Right now I have only one data set, so I'm getting this data. So also you can see, you can choose variable, which variables you want to use or which variables you don't want to use. And right now we want to use all the variables, so let's validate the important data. So here there is my GitHub page, LinkedIn. Please connect with me or share your comments and just unite together, and maybe we came up with something that is really interesting, right? So as you can see, there are 4 parts: data, EDA, exploratory data analysis, model, and we can use, and let's see what happens. So the first thing that you will see here is the data map. Also you can browse the data set. You can just upload your data set that you want to examine. It do everything automatically in a reactive manner. So first of all, there are 3 value boxes, which shows how many observations there, how many variables there, and how many missing values on the data set. And this is like a high level view of the data set, how it looks like. On the next page, you will get the high level descriptive analytics of the data. So first of all, we get a data frame summary, like it says how many variables are there and how the variables, whether they are integer, whether they're numeric or string, and etc. It gives us descriptive statistics. It gives us also the quality measures, like how many data is missing, how many distinct values are in the data, and etc. And the next one, as we know, the very important thing for us as a data scientist is also the understanding the distribution of variables. And this, my tool is very good to understand, to plot not only categorical variables, but also continuous variables. So it's very scalable. So you see how our variables are scaled and how they are actually distributed. And this is the auto plot. So this is our esquisse that I was showing to you guys. So you can easily, how you can just drag and drop. Let's say I'm just dragging here, and you see I'm just automatically, with a click of a button, I'm just plotting my visualization. Also, I can just name it like distribution, and also I can get a code. You see, I can generate a code here, and even I can just save it as an image. You can see it here. Yes, you see, distribution, and it's very easy. You see, guys, it's very straightforward. It's very easy to navigate also, and it's very good for the people who has very like limited or just starting to learn the coding or data science stuff. It's very cool. Thanks for the Dreams Art team also. And also, this is a very important part. This is like our favorite like red button where we can just do our H2O. So here, first of all, we will select our target variable. And here, let's say we are selecting all the variables. Let's say I have 13 variables. For demo version, I just try to speed it up. Let's see how it's training the data set. So now we just click the run button. So let's wait how our model is being trained. So
I just want to mention that we have 2 more minutes.
Yeah. I'm just about to finish. So this is our our leaderboard here is GLM, general linear models. So we can get the coefficients for each coefficient estimates for each variable, and also we have magnitudes of how each variable is impacting on our decision, whether it's positive or negative. It's a global, you see, this is a global interpretation. But also we here have a LIME. What is LIME? As I explained before, it makes the prediction of the model for each observation. Here, for example, I can choose any observation. Let's say I want to choose observation number 27, and it gives interpretation of each variable impact on this specific observation. Here you can see only 2 variables are actually important for me, or actually contributing to make my decision for the observation number 27. But if you go maybe to 46, observation number 26, it can be a bit different. Now you see the red ones, which are saying that they're impacting negatively to make this decision, while the blue bar chart, like bars, are saying that whether they are positively contributing to make this prediction. And also, what you can also do here, so you can view our predictions. So let's say we are trying to choose our, let's say here our primary key is like our number of observations. And now this is like observation number, this is our prediction, and this is a standard error. And what I can do here easily, I can just export it as an Excel sheet. So you can easily navigate and see your predictions. So this is a very high level introduction to my model. And also I would like to acknowledge these people, this amazing community here. They built a very good stuff using LIME, H2O, and etc. So deep dive on that, guys. It's really helpful. It's really amazing. So we love data science. We're hungry about data science, and that's really awesome. So if you have any questions, people, please feel free to ask. And also, I will upload this presentation deck so you can go to these links and see and absorb more topic and understand how H2O actually works with LIME and etc. So I'm finished. Sorry, I just was like 1 minute late.
No problem. Thank you so much for your presentation, and thank you all for joining us today for the webinar. I guess that you can reach out to him directly with further questions.
Okay.
I guess you can share your email address in case, I mean, if it's okay with you. So if people have more questions, because I can see that there are a lot of new questions in the Q&A section. I think that you can proceed with your communication.
Sorry?
I can see that there are more questions in the Q&A section. Yeah.
So are you trying to end up with the webinar, or it's still open so that I can answer their questions?
Our webinar is until 1. I think that
Thank you, Pamela. Thank you for your comments. That's really awesome. So Yeah, we can work on the coronavirus too. That's really important. I will share on my GitHub, I will share my presentation deck so you can look at it. Juan, what alternative to H2O? For H2O, you can use Data Robot, but you have to pay for it. Also, you can use different kinds of R packages like Caret in R, or maybe scikit-learn, or yeah. So how I can make this presentation deck accessible for everyone?
We can email this presentation to all the attendees.
Oh, you can do that? Sure.
Yeah,
I will.
sure.
Thank you.
Thank you so much.
Thank you. Have a good one.
You too.